Hi, my name is Bahadur Akhmedov. Welcome to the course of Probability and Statistics. In this video lecture, we're going to talk about law of total probabilities. Previously, we talked about the two fundamentally important rules of the probability, which is called the additional rule and the multiplication rule. The additional rule tells us that, hey, if you would like to find the probability of the A or B, what you need to do is you just need to find the probability of the A and add this to the probability of the B. And at the same time, the multiplication rule tells us that if you would like to find the probability of the A and B, what you need to do is you just need to find the probability of the A times probability of the B. So of course, it is the simplified version of the formula. So this formula is for the mutually exclusive events. And this formula works for the independent events. But in general, this is the general concept of the additional rule and the multiplication rule. These two fundamental rules are so important for the probability theory in general. So they are the necessary tools which we have to know. And for the introduction level, they are even sufficient. So you can find the probability of almost any problem just by using them. So for example, let's solve this problem, which tells us that, hey, there are 3 independent experiments are going to be conducted. So probability that the first experiment is successful is 0.5, the probability that the second one is successful is 0.6, and the probability the third one is successful is 0.7. So I'm going to make the notation. So let's say A1 is going to be the first experiment. Probability that A1 is successful is equal to the 0.5. Probability that the second one, A2, is successful is 0.6. And the probability that the third one is successful, A3 is successful, is equal to 0.7. And what we need to find is, we need to find the probability that whenever we do the 3 experiments in a row, exactly 2 of them are successful. So in order to find this, we are going to use the multiplication rule and the additional rule. So, whenever we have these 3 experiments, they might be in a row. For example, it is possible that A1, the first experiment, is successful, the second one is successful, and the third one is successful. So all of the experiments are successful. So in order to find its probability, what we have to do is we just need to multiply their corresponding probabilities. So this is the case when all of these 3 experiments are successful. But we need to find something else, right? So we need to find the probability that only 2 of the experiments have to be successful. The third one should be always unsuccessful. So I'm going to find the probability of the series of the experiments where the first one is successful, the second one is successful, and the third one is failure. So that is why I'm going to denote this with the prime, which is going to be the complement of the event. So if for example, the third experiment is successful is equal to the 0.7, and the probability that the third experiment is not successful is going to be 0.3. It is its complement, right? So if you remember, probability of the A3 prime has been found by just subtracting probability of the A3 from the 1. It is going to be equal to the 0.3. So let us find this probability. It's going to be equal to the probability of the A1 times probability of the A2 times the probability of the A3 prime. And I can just multiply the 3 probabilities because of the multiplication rule or the AND rule. And since the experiments are independent, I can just multiply them without using the conditional probability. Is it the only case when in a row of the 3 experiments, exactly 2 of them are successful? So the answer is no. So there are other cases when the experiment of the 3 is going to have exactly 2 successful cases. So the second one, for example, is going to be the first one is not successful, but the other 2 are successful, right? So this is one case. The second case is going to be the first one is successful, second one is not successful, and the third one is successful. And as we wrote before, the third case is going to be the first one is successful, second one is successful, the third one is not successful. So we can find out those probabilities by just multiplying the corresponding probabilities. So A1 prime, A2 to the A3. So the A1 to the A2 prime to the A3, or A1 to the A2 times to the probability of the A3 prime. So this is the probability that the experiments are going to happen exactly in this order. Probability that the experiments are going to happen exactly in this order is going to be this one, and this is going to be the probability that the events are going to happen exactly in this order. So finding the probability that exactly 2 events are going to be successful means that the events are going to happen either in this way, or in this way, or in this way, right? It means that we need to use the additional rule, and we need to find the probability that exactly 2 events are going to be successful by just adding the 3 probabilities. So this is the problem, which is like really good structurally, because it reveals the situations where we have to use the Ball's fundamental rules, like a multiplication rule, when we need to find the probability of happening the experiments exactly in order as we wish, and the additional rule, where we have different possibilities of getting the success, getting the exactly 2 successes in our example. The problem is, so we've considered the simple example where the 3 experiments are independent. The problem is whenever we have the experiments which are dependent, the things are not becoming so easy. So we need to use or build the new other tools in order to find the probabilities. For example, so let's say you've got the box. Inside of the box we have a couple of balls. So not couple, but many balls, let's say. So there are 3 yellow balls, 2 pink balls, and 1 white ball. What I would like to do is, let's say 3 yellow one and 2 pink balls. So we can easily find that whenever you choose one ball, we can easily find the probability that the first one is going to be yellow is going to be equal to the 3/5. We can also find that whenever you choose the ball at the first time, it's going to be the pink ball is going to be equal to 2/5, right? So let's make an experiment. We choose a ball, and we don't put this back to the box, and we don't replace this back. Replace the ball back to the box. And then we are going to choose the ball again for the second trial. So what I would like to do is I would like to know what is the probability that the second ball is yellow. So please note that we don't know what is the first ball. So again, let me explain you the problem. So there is a box. Inside the box there are 5 balls. Some of them are yellow and some of them are pink. So whenever you choose the ball first time, you see the color, or you don't see the color, and you don't see the color, and you don't put this ball back to the box. So you don't know what was the first color. So you would like to know what is the probability that the second ball is going to be yellow. So we are going to try to find the solution for this problem. So the probability the second ball is going to be yellow. So there are 2 possible situations where the second ball is going to be yellow, right? So either you choose the first ball as yellow, right? And you are going to find the probability that the second ball is yellow if the first ball is yellow, right? You understand the situation? So this probability means that first is yellow, right? You know that the first one is yellow, and you're finding that the second one is yellow. And it will help you to find that the second ball is yellow because you know that the first one is yellow. And we also are going to multiply this to the probability that the first one is yellow, because we want these two events happen exactly in this order. The first one should be yellow, and then what is the probability that the second one is yellow if the first one is yellow? If you remember, this is the conditional probability. It basically tells us that, hey, this event here, the second one, after the vertical line, is already happened. Is already happened. So is it the only case where we are going to have the second ball as yellow? No, there is another situation. It is possible that the first ball is pink, right? So the first ball is pink, or we can say that the first ball is not yellow. And we have to multiply this to the probability that the second one is yellow if it is given that the first one is pink or it's not yellow. There are only two possibilities, right, of getting the second ball as a yellow. Whenever the first ball is yellow and then the second ball is yellow, or there is another situation where the first ball is pink, it is not yellow, and the second one is yellow. So we need to add them because there are only two possible cases. So let's find the probability here. So the probability that the first ball is yellow is 3 over 5. So now, if you choose one of the yellow balls, right, you then put this back. So how many balls you have? You have 4 balls, and 2 of them are yellow. So that is why probability that the second ball is yellow is going to be equal to the 2 over 5 plus. So let's write down the original situation. Again, now we need to consider this probability that the first ball is not yellow. So you have 5 balls, 2 of them are not yellow, and the probability of choosing not a yellow ball is going to be 2 over 5. So we assume that the first ball is not yellow. So the event after the vertical line is already happened. We know that this has already happened. So basically, we choose one of these balls. So now inside the box we have only 4 balls and only 3 of them are yellow. So what is the probability that the second ball is yellow if you know that the first one is not yellow? It's going to be equal to the 3 over 4, right? We're going to multiply this to the 3 over 4, and we can calculate the probability. In this case, it's going to be 6 over 20 plus 6 over 20, or 12 over 20. So this is how we can find the probability when the events are dependent, right? So whenever you choose the ball, the second ball, the probability that the second one is going to be yellow or pink is obviously going to depend on the result from the first trial, because you're not putting the first ball back to the box, so you're changing the probability. So these two events are dependent. So the result of the second event, second trial, is obviously going to depend to the result of the first trial. So in such a cases, we need to use this rule, and this rule is going to be called as the law of total probabilities. So do you see this? So in order to find the probability that the second one is yellow, we found the 2 cases where the first one is yellow and the first one is not yellow. In general, we can write down this rule in this way. Probability that of A is going to be equal to probability of the B times probability of the A if B has happened, or probability of the B prime times probability of the A if B didn't happen. So this formula is called as the law of total probabilities. Law of total probabilities. So we are going to use this law lots of time, especially whenever we would like to find the conditional probability. And in our next lecture, we're going to introduce so-called Bayes theorem, which is going to help us define the conditional probability. But one of the most important feature, things in the Bayes theorem is the law of total probability. So you can compare these 2 formulas and you can see that they are basically the same. Thank you.